Hey, what's up, everyone? This is your boy James. Welcome back to the How to Learn Data Science Python episode number 10. Today, we're just gonna keep going with our study on the. This episode is about like introducing the relational database, kind of like part of the study of import data to the Python part one in the data camp. So let's see what Hugo is kind of talking about in this YouTube video. This video.
You've already mastered the art of importing all types of single files in Python. Congratulations! However, to earn your daily bread and butter as a data scientist, you'll be required to interact with more complex data structures, such as relational databases. Now, what is a relational database? It's a type of database that is based upon the relational model of data, first described by Ted Codd in the late 1960s. Before getting too theoretical, however, let's check out an illuminating example, the Northwind Traders database, a synthetic database that contains sales data for a fictitious company. Firstly, a database consists of tables. Here you can see three tables from the Northwind database: orders, customers, and employees. So what's a table? A table generally represents one entity type, such as order. Notice that this table looks a great deal like a data frame, and that's the point. In a relational database table, each row or record represents an instance of the entity type. In this case, each row is an order. Each column represents an attribute of each instance, such as the order date in the case of orders. In this sense, a table is entirely analogous to a data frame. It is essential that each row contain a unique identifier, known as a primary key, that we can use to explicitly access the row in question. In our orders table, you can see that the key is order ID, the first column. But recall that a database consists of many tables. The really cool thing about relational databases is not merely that you have a bunch of tables, but that the tables are linked. Now, how this linking works is ultra intuitive. See that the orders table has both a column called customer ID and one called employee ID. These columns correspond precisely to the primary keys in the customers and employees tables, respectively. So, given an order, you can immediately look up the details of the relevant customer or employee. This is super cool because it means that you don't need to store all the customer details such as first name, last name, company with every order that they place. You merely need to look it up in the customers table. This saves an incredible amount of space. As stated earlier, the relational model was originally proposed by Ted Codd and has been widely adopted. There's a great deal to the theory, but it's most neatly summarized in Codd's 12 rules, also known as Codd's 12 commandments, which he developed in the early 1980s to combat what he viewed as a dilution of his original relational database vision. Codd's 12 rules actually consist of 13 rules, but they're zero index. That is, the first rule is labeled 0. If this makes you laugh, you're definitely a geek like me. These 13 rules were defined to describe what a relational database management system should adhere to in order to be considered relational. Among the most popular of such systems currently are PostgreSQL, commonly called Postgres, MySQL, and SQLite, all of which use the SQL query language. In fact, SQL itself is actually an acronym for Structured Query Language, which describes how you communicate with a database in order to both access and update the information it contains. The term querying is really just a fancy way of saying getting data out from the database. Next up, you'll learn how to connect to databases, but before that, let's make sure that you have a solid conceptual grip on the relational model.
Okay, pop creates the relational model. Which of the following is not part of the relational model? Each row or records in the table represent the instance of an entity type. I think each column type represents attribute of a feature. Yes. Yes. Each table contains a primary key, which is a unique entry of each rows. Database consists at least three tables. I don't think that's the case. There are relations between two tables. So number four. Great.
Alright, we're back. What we really want to do is to get our data out of our database using SQL, or the structured query language. But before we get to that, we're going to need to figure out how to connect to a database. We'll use a SQLite database as an example because SQLite is fast and simple while still containing enough functionality to introduce you to all the necessary concepts of querying a database. There are times when you would prefer to use Postgres or MySQL, but for our purposes here, an introduction to interacting with relational databases in Python, a SQLite database is perfect. We'll once again look at the Northwind database. There are many packages we could use to access a SQLite database, such as SQLite 3 and SQL Alchemy. We'll use SQL Alchemy, as it works with many other relational database management systems, such as Postgres and MySQL. So without further ado, to connect to northwind.sqlite, we need to import the relevant function createEngine from the package SQL Alchemy. We then use the function createEngine to fire up a SQL engine that will communicate our queries to the database. The only required argument of createEngine is a string that indicates the type of database you're connecting to and the name of the database. Next, in order to query the database, we need to connect to the engine to do so. But before we do this, we would like to know the names of the tables the database contains. To do so, apply the method tableNames to the object engine. This will return a list of the table names that you can then print to the console. Now it's your turn to do the same. Fire up that database engine and print out those table names. After this, I'll be back to show you how to connect to the engine, how to query your databases, and then you'll get loads of practice writing your own queries to import data from relational databases.
Okay, let's get it done, right? So first, to create a database engine. Database called the Chinook SQLite. Northwind SQLite is the website, or let's say, website data source. And here's the SQLite is called the connection string to SQLite database of this Northwind SQLite. A little bit background of the Chainhook database. Chainhook database contains information about the semi-fictionary dictionary, digital media store in which media data is read and the customer input in cell have been manually created. Namely, the sample database are based on Northwind database, SQL nodes, chain nodes are winds in the internal west of the North America, which Canada, present Great Plains of various mountain range into Chinook are most prevalent over the southern Alberta, Canada. Chinook is a good name to the truth of database. I cannot agree. Tend to be an alternative Chinook. Import of the function create engine from the module SQL Arching. Oh man, what it is? So hard to pronounce. Connection SQLite database and the scientific engine. Okay, from so we saw the video, right? Like create from this is the function SQL Archer. Is that the right way to? What is this? SQL origin? Open source SQL tool, key tool to object-oriented mapper. Let's see how to pronounce this. Just give me 1 second, guys. How to pronounce
SQL Alchemy.
SQL Alchemy. Thank you for waiting. Okay, SQL Alchemy import from create engine, which is library, I believe. And then we just need to engine equals to create engine. This is the connection. Connector? Can we call it a connector? Maybe we can call it a connector. If you know that, let me know on the comment section. And yeah, Northwind and SQLite. Submit. Something's wrong because this is lowercase. Run. What do we got here? So assign to engine. Yes, I think that's the thing. SQLite slash Northwind. Oh, change SQL. So this is a subset of that. Going to first here, create an engine to connect to database. Oh, okay. So this is actually the right database. Change SQL. How to pronounce? Is that Chinook?
Chinook.
Chinook? Okay. Here we go. What's the table in the database? Database Chinook? SQL. Table names. So include necessary module from copy import create engine. Create engine. Yes. Engine equals to create engine. SQLite. Let's search and chain Chinook. SQLite. Save the table name to the table names, right? Table names equals to table names equals to the engine. Table names engine. So use the methods. The method table name and the print table names. Okay, table names and engine. It's a method. Name table names not defined. Chinook to verbal table names. What are you talking about? Let's do, okay. This one. No. Table names equals to table name. Oh, method. This? Exactly. This one should method should dot method because this is the method. Because this is the method over here. So method is like it have a dot in the method. If you don't know which method, you hit the tab to show up here, and you just go down, choose table name, but you forgot the parentheses. And now we just print it out. Okay, so we have all artist, the customer, employee, blah blah blah. Next,
Now that you've figured out how to create a database engine and to list the tables of the database in question, it's time to connect to the engine and to query the database. Once again, the term querying is just a fancy way of saying getting data out from the database. The hello world of SQL queries is select star from table name, where table name is the name of any of the tables in the database. This query returns all columns of all rows of the table of interest. For example, I could query the Northwind database with select star from orders, and this would return all columns of all rows of the orders table. The star after select means all columns. Straightforward, right? Well, nearly. This is an SQL query, and we need to figure out how to make such a query using Python, SQL Alchemy, and, in fact, we'll also use pandas to store the results of our queries. The workflow will be as follows. You'll import the required packages and functions, create the engine, connect to it, query the database, save the results of the query to a data frame, and then you'll close the connection. Let's now check out how to do each of these steps.
Let's just go back a little bit.
To these steps. Let's now check out how to do each of these steps.
If you didn't get it, let's see. Import package first to create the database, connect to the engine, query the database, and then save the query
to a data frame. And then you'll close the connection. Let's now check out how to do each of these steps. Create the engine using the function createEngine. To connect to the database after creating the engine, you create a connection object con by applying the method connect to the engine. To query the database, apply the method execute to the connection con and pass it a single argument, the relevant SQL query. This creates a SQL Alchemy results object, which we assign to the variable rs. To turn the results object rs into a data frame, we apply the method fetchAll to rs and save it as a data frame using the pandas function dataFrame. FetchAll fetches all rows as you would expect. To close the connection, execute con.close. Don't forget to do this. You can then print the head of the data frame, as we have done before, as a sanity check. All the rows look good, but the column names aren't quite correct. To fix this, before closing the connection, you can set the data frame's column names by executing df.columns is equal to rs.keys. One last note. Analogous to what you saw in Chapter 1 when opening plain text files, you can use the context manager construct to open a connection, which will save you the trouble of closing the connection later, or save you the trouble of forgetting to close it. There are two other differences that you may have noticed between this and the previous code. Firstly, I no longer have select star in the SQL query. I now have column names of the table orders. All this does is it imports those particular columns and no others, whereas select star imports all columns. Secondly, instead of applying the method fetchAll to the results rs, I apply the method fetchMany with the argument size equal to 5. This imports 5 rows instead of all rows. You'll become better acquainted with these functions and arguments very soon. Now that's enough out of me. It's time for you to practice writing your own
Let's see.
SQL queries and to
How we do
import
that.
data from your database. Enjoy.
All right. So let's see. First, hello world SQL query. Time to lift off. Perform hello world SQL query. Select in order to retrieve all column from elbow Chinook database record the select all from. Right? That's easy, right? So like open engine with com and com equals to engine dot, let's see, do we have something? Do we need to run this first? So run this first and oh, by the way, it's a control enter, so you select the lines and control enter like RStudio. Okay, here, so you have the engine here, right? So let's see what we have here. Should have a connect, yes. Connect, and you execute, I believe it's single like, quotation, maybe it doesn't matter. Lowercase, I think it's not matter. Select from and com. That's probably PD data frame from rs dot fetch all because you got fetch all, right? And close the connection. How to close? Man, I don't know how to close. I forgot. I didn't mention it. How close? df.close. So I want it first. Okay, something's wrong. Select the from com. Paste. Oh, can't execute. Here should be. Select from engines now, right? What's the data? Yeah, engines are data. It's not right. Connect engine. Think of what's the error. No such table engine. Is that right? Here's not right. No such table. So engine's not doing execute code. Oh, engine's not the table. It's a variable of the database or object of the SQL maybe. But the here elbow should be name. Right? Here we go. How about that? Lowercase, I think it's okay. Good. So you fetch all, right? rs fetch all and df. So if we don't run this row, tab, nothing. Run this row here, nothing. Oh, here we go. Close. Let's see. I think it's like this. Oh, attribute of close. How to close? Can close the method on the engine. Oh, engine connect. So you not close the data frame. Makes sense. You close this guy. Connection. So this is called a connection. Close the connection, right? Here we go. So 1, 2, 3, 4, 5. This one, the headers make not right. Maybe next round he will ask us to fix the header. So you got the here's the album name. I don't know. This is the album ID. Let's see. Next round we will figure it out. So customize Hello World SQL query. Select the specific column for table. Select the specific number of rows. Import column name to database table. Okay. Yes, we record that. And the package have already been imported as following from SQL. This guy, it's hard to pronounce. SQL Alchemy, import create engines, Redmond create engines, withhold something connection has come. Let's see. Execute SQL select last name and title from employee table store results RS. Arranging the context, contact RS equals to. Should we put a card here? Okay. Connect. Connect. You already connect. Execute. Execute. Here. Select. This will not work because the select you should either all lowercase or uppercase. Select last name, title from title employee. RS fetch name. Why don't you fetch all? Size equals to 3. Should I put 2 over here? Column name equals to RS. Let's see. Need to select one attribute connection object have no attribute execute. Oops. Execute. Oops. Here we go. SQL select last name title from employee. No such table. Employee. There's no L. Here we go. And 3. Header. Yes. Last name and title. So let's try something. Like let's change this to uppercase S. Is that working? Okay. Still working. How about this? Still working. Okay. So it doesn't matter. Why don't we? How about let's fetch? Okay, so it's working. How about let's fetch? Oops. Let's try something like very quick, I promise. RS and the com, so execute, right? And so you select last name, title from employee, right? And here you just like RS that fetch. What if we fetch all? What's gonna happen? RS like this. Is this still working? 8 rows. Okay, so still working. The total is like, wait, total is 8 row, but why you just print? Oh, fat is 5. Maybe I just like print. Oh, how about I just print? Mm, yeah, here we go. 0 to 7. Actually, only have 8 rows, so fetch all is just like fetch all of them. So here we go. Next one, filter database record user SQL where. So I believe you guys already know SQL. Select everything from customer where country code to Canada. Okay, we got filter, right? So let's skip this part. We probably already know that. Import Panda. I already import Panda. Okay, from SQL Acme import create engines. Create the argument here of create engine so that you engine of the SQLite database. Chain it SQL. So try SQLite dash dash slash 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 backslash. Oh my gosh, so many. Chinook SQLite. Okay. Well, we're perform query servers identifier DF. Open this, execute, select. What do we select? Select all the record from the employee table where employee ID is greater than 6, assigned to RS. Everything from employee where employee ID equal to 6. And here is data frame and RS. You're gonna fetch all column name then RS equals RS keys. Let's see if it's working. Employee. No such column employee. Employee ID. Okay, good. It's working. Next, order your SQL record with order by. So select from customer order by super reps ID. So here, create an engine from the Chino SQLite and assign to the engines. And in text X, you're required to select all the record from the employee table and order them into increase order by their birthday assigned to the RS. and then call the pin.df, apply to fetch to rs, and then store in the df and set the name corresponding table name. Okay, same or same. First, so we get a con, right? First, engine equals to create engine SQLite. We have Chinlock SQLite. Execute this guy. Select everything from select everything from employee and order by increase order by the birthday. I think if it's something set false, then you can change it to decrease order. Panda data frame. IS fetch or LIS let's see if it's right. Good. Good. Where is this thing? Did you create a specific body? Equals to IS keys. Yes, I did. Oh, DF. Oh, RS. RS is the query object. Here we go. So we've got the last name, first name, email. Ta-da! Okay, query the database directly from pandas.
You've seen that. After creating a database engine, you can get the results of any particular query using only 4 lines of code. Connecting, executing the query, passing the results to a data frame, and naming the columns. 4 lines of code is pretty good, but you can do even better. You can actually do it in 1 line, utilizing the pandas function, read SQL query, and passing it 2 arguments. The first argument will be the query you wish to make. The second argument, the engine you want to connect to. And thus you can achieve the same as this code by executing this single line. The power of pandas. In the following exercises, you'll gain more expertise in writing SQL queries and using pandas to execute them. What are you waiting for? The end of this video? Let's do it.
Okay, let's do it, guys. So Panda hello world SQL query, right? Like this example, DF Panda read the SQL query select from orders engine. So import pandas from China. I like panda. SPD and here engines create a connection equals to create engine the SQLite and the chain of light. And here, first code panda. Let's just type everything. Just panda SQL code. Make myself remember. EF equals to panda dot read SQL query select. What do we select for? Select all from elbow. Right? Print header open query contents manager store query and df1. Same thing. See, are they different? Com. Oh, here. Engines. Connection object. Engine for the SQLite. Here we go. Print equal true. Okay. So true means those two are the df and df1 the same. So which means this query is working. So this next one, more complex query. Hi, you become more familiar with the read SQL query. To using execute a more complex select statement following both where and order by. Okay, we can handle that. So first, the engine equals to create engine. Engine equals to create engine. SQLite. Question mark. SQLite. Execute the current story. Yeah. Execute course P and read SQL query select everything from employee where employee ID equals to 6 and order by I don't know this first date. Com. Oh, miss again. I need to here. First day. Here we go. So you can see like employee ID. Where's the ID? Employee IDs great the A76 or great equal than 6, and the order by birthday. So birthday oldest and to youngest. Here we go.
By now, you've become familiar with
Explore the
querying
relationship
individual tables of
data
databases,
tables.
such as the orders table of the Northwind database. You'll remember, however, that much of the power of relational databases stems from the fact that they can capture relations between tables. The tables are linked. For example, as we saw earlier, the orders table of the Northwind Traders database has both a column called Customer ID and one called Employee ID, columns which correspond precisely to the primary keys in the customers and employees tables, respectively. This means that, given an order, you can immediately look up the details of the relevant customer or employee in the appropriate table. Now, what if you want to incorporate such information into your query? For example, if you want to query the orders table and include for each order information about the corresponding customer from the customers table. A specific illustrative example will go a long way here. Let's say that we wanted for each order to get the order ID and the company name of the customer. The order ID lives in the orders table, while the company name lives in the customers table. SQL has a really clever way of doing this. It's called a join, because what you're really doing is joining two tables together. In this case, the orders table and the customers table. Specifically, it's an inner join. There are also other types of joins which we won't cover in this course. As it's the customer ID columns of the orders and customer tables that correspond to each, you'll want to join the tables on these columns, and that is precisely what I've done in this code. The notation of dot followed by column name is merely selecting a column of a table. The table that we are selecting from is orders inner join customers on orders.customer_ID equals customers.customer_ID. And I am selecting the order ID column and the company name column of this new table. I know that that's a bit to take in, but after you get your hands dirty performing some of your very own inner joins, you'll be far more comfortable with this advanced querying technique. It's your turn to query.
So for if you guys didn't see clearly about this core, I think so basically this one he wants us to do it in the join, right? Copy paste over here. Let's just explain this one. So select those two column name, order ID and the company ID from order table, and in the join this customer tables on the order ID equals to customer ID. So based on the video he showed, I believe like the order ID is the primary key from this order table, and the secondary key in this customer tables. So what he asked, aside the RM results from the following query, select all record, extract the title and the record name from artist, each record from elbow table and the artist table respectively. To do so in a join those two table artist ID. Great, he told us already how to do that. Assign a RM. Okay, let's see what are we gonna do here. So perform a query and save results in the data frame. Why give us 3 lines? Is that gonna take long? Let's df equals to and ed read SQL query, right? And then we just type over here. I think you want us to just, extra row. Select title name from I don't know how that works. from Albert, right? Inner join artist on elbow ID over the artist equals to if you flip those two, I think like the order of the oval and artist, you should get the same results. From artist artist. Why we need to oval the artist ID and artist ID or just artist ID directly? Because it's obviously because uh, cannot do that because you don't know where this one come from, where this artist ID come from. So that's why. And here, first the com, right? Like obviously, like I missed something. You're gonna first engine connect. You're gonna execute. So this one actually goes to here. And here should be right rs equals to com execute. You're gonna call this one. Wait, why you give me like 3 rows? Oh, okay. So you want the old methods, like, but why you need pandas? Like, if you want the old methods. Oh, panda data frame. Or this old method. Panda data frame rs dot fetch all. You want me fetch all? Okay. And df the columns. True. Rs the keys. This one, let's see if it's working. This. Okay. Syntax error. Select title name from elbow. Inner join. Did I spell that wrong? INNER. Inner join artist on elbow artist ID. Oh, this is artist ID. We have here syntax error. Just IDs. Artist ID equals to artist ID was. What's the problem? Oh, from. How about now? Here we go. Good. Filter your inner join. So inner join and order customer ID table from Northern Wind database. Here you execute. So we want to filter play track inner join track and play track track ID for try to satisfy condition. Millisecond lesson 2500,000. Yes, equals to panda SQL read SQL select everything from not everything select okay, it's really everything from playlist track in the join track playlist track track ID track ID where a second. Oh. Oh, every time forgot the connection. No such column millisecond. Is that smart enough to figure it out? Okay, where did this millisecond come from? Bubbles. Okay, let's figure out where this millisecond come from, right? So like we can copy this, select everything from playlist, right? Like see if that's the case. We can just print play ID track ID. We don't have this one. So let's say that from the track. Okay, obviously it's from track. So the milliseconds from track. Here, I mean, obviously I already submit and I got the points, but the thing is, what if we mess up the order of inner join the track playlist? We just flip those two. Let's see how that go. I think it will give an error because the milliseconds from to track, and now it will be default as not as here. See if it's played out fine. Oh, okay. So it's smart enough to pick it up. Oh, let's go next one. Final thought. Final thoughts.
Congratulations on doing so well in a crash course on relational databases. Whether you've seen them before or not, you're now able to create engines and connect to them in Python, perform simple select queries, filter your results using where, Perform more complex queries such as join and store all your querying results in pandas data frames, among many other things. These skills will get you a long way in using Python to import data from relational databases. In fact, having made it through this course, you are now well equipped to import all types of files in Python, from plain text to flat files, Excel to MATLAB, among many others. Well done. But that does not mean there's not more to be learned. What about importing data from the web, where so much of it is stored? In the sequel to this course, you'll learn how to import web data. It's a short course and will equip you to import data from the World Wide Web and pull data from application programming interfaces, also known as APIs. You'll take a deep dive into the Twitter streaming API, which allows us to stream real-time tweets. I'm sure that you're itching to get your hands dirty with web data.
Oh, yeah.
So I'll see you in the next course.
So I hope you enjoyed today's episode. And yeah, I'm just going to say that next episode, I'm probably going to show some more SQL since this is kind of a SQL course. And I should, my first episode is about the SQL. And yeah, I'm just gonna do some more advanced SQL, and some people also leave on the comments that they want to hear more about the SQL. So next episode, I'll probably shoot advanced SQL. I don't know if I remember SQL that well, but I'm gonna try my best. So just being true, and I see you next time. Peace.